Now that everything's going, get started. Now, in whatever chapter we're in, I don't know which chapter it is, y'all have to remind me.
6.
Yeah, 6. We did 6.3 or 6.2. We learned that you take any type of equation and solve it, you're going to get a solution. So if we take and multiply through by 6, that's going to give us 3, 2, and then we distribute the 3 and the 2, and we get 3x minus 9 is equal to 2x minus 4. And the 2 comes over, that leaves us with x. The 9 goes over, that leaves us with 5. So x is equal to 5. Now what does that number do? X is equal to 5. What does it do to the equation?
Positive,
Say again.
positive, or like on the graph.
If you plug in that 5, what will it do?
It'll equal the equation.
It'll make both sides what? Equal. And so it is the solution to this equation. So it is is this the only solution? Yes or no? Yes, it is. That is the only solution in our number system that will make that equation work. Now it's important that you think about that before we go into inequalities, because inequalities, you have a set of numbers that work. This is the only number that will make this equation what? Equal to each side. Okay? And that's 6.2. Now the section we're going in today is a continuation of 6.2. You solve the problems the same way, especially if you keep your variable positive. And if you keep your variable positive, everything's done the same way. So let's take a look at a simple example of 6.5. Somebody look and tell me if that's inequalities.
6.6.
6.6. Inequalities. Before we get started with inequalities, you've got to write down the following things. These two guys and these two guys. These two guys are represented by parentheses or an open circle. These two guys are represented by brackets or a closed circle. Now, what I mean by brackets in a closed circle. Anytime we give an answer to a solution set, that means more than one number, you have to use some kind of location on a number line and some kind of notation, interval notation or set builder notation. And we'll get to that in just a few minutes. So this is the only thing really that you have to learn that's new. Or it's not really new, but some of you haven't seen it in a while. Okay? And if you ask me in the next couple of days when we're going over problems, somebody's going to say, well, how did you know to do this? And I'm going to refer back to this. So you need to learn it. These two, they're not equal to. If they're not equal to, that means they don't touch the number or can't be located on the number line. This means right here, what does that mark right there mean? That means equal to or equal to. And that means that you do include that number, meaning if x is greater than or equal to 3, you do include 3 in the solution set, and you can locate 3 with a closed circle. That means you can use 3 or use that number. Now let's take a look at an example. We used to do 2x plus 3 is equal to negative 3x plus 7. All right, that's what we used to do. This is an equality, and we solve it the same way. That negative 3 will come over and make 5x. That negative 3 will come over and be 4. And x is equal to 4/5. And as I said before on the previous problem, that is our only what? That's our only solution in our number system. The only number in the universe that will make these two sides equal. And again, that's 6.2. The only difference is now 2x plus 3 is equal to negative 3x plus 7. I'm going to take the equals out, and I'm going to put an equality there, inequality there. Solve it the same way. The negative 3 comes over, that gives you 5x. Brings 3 across the river, that's a minus 3. 5x is greater than or equal to 4. X is greater than or equal to 4/5. Now, where this is just one solution to make this equal, this is a number of solutions that makes this true. This makes it equal. This makes this true. So, what is 4/5? 4/5 is close to 1, right? So, if x is greater than or equal to 1, the first thing I tell students to do, if you've ever been kind of shaky about inequalities, always graph it first. Always. So, you go over here and you graph it. This arrowhead is called negative infinity. This arrowhead is called what? Positive infinity. It amazes me how many students don't know that. I guess it's not on some kind of test. 0, 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. Now, with this, how many location points are on this? Just one. Where is it? 4/5. So, I'm going to put this in red. X is equal to 4/5. 4/5 is almost 1. It's right there, and I put a little dot right there. Now, did I make it little for a purpose? Yes. Because all that does is show where that 4/5 is located. Because that's the only solution to the problem. That's it. 4/5. That's it. But this says that all my answers, all my solutions for this problem is above what? Above or equal to what? So it's above or equal to, so I got to put a closed circle. or a bracket if you wanted to. Brackets are usually used with the notation. And then what numbers are greater than 4/5? To the right or to the left? To the right. So you shade these numbers. Now, that's nice and dandy, but we got to write it in some kind of notation because we got to hold our pinky up and be impressive at parties. So we got to write it in some kind of notation because that's basically all it comes down to, because this is good enough for government work. This right here is an answer. I mean, that's the solution set. But we have to write it a little bit better. Now, there's two types of notation.
I thought that was less than or equal to. Am I doing
There is no, you don't read the, you don't, that's a common mistake. I'm trying to draw, and you know, you guys can't do this very well, do two things at one time, so you just don't have to hold on a minute. I want to delete the thing. Forget it. Just take it and erase it. And if you noticed, I'll tell y'all something. Did y'all notice when I wrote this, did I say less than or equal to or greater than or equal to? Or did I say these guys? I said these guys. Because you don't know what they are until you put numbers around them. Well, I was always taught this was less of. No. You cannot. You can't say this is this or this is the other thing. You cannot do that because you don't know what's on this side and you don't know what's on this side. I could easily put, I could say this. 2 is greater than 1. I could say 1 is greater than 0. I could say 1 is less than 3. You see what I'm saying? Or I could say 3 is what? Greater than 1. If somebody tells you that one goes one way and the other one goes the other way, they're crazy because you don't know what's going to be on the side. I can say this is 3 is greater than 1, or I can say 1 is less than 3. What about this? 4 is greater than 5. I'm sorry, that's wrong. Duh. I meant to draw it the other way. 5 is greater than 4. Or 4 is what? Less than 5. So that debunks the little, if the alligator goes this way or if the alligator goes this way. Because I can say 4 is less than 5, or I can say 5 is greater than 4. Up here, I can say 1 is greater than 0, or 0 is less than 4. I can say 0 is less than 4 here, or 4 is greater than 0. You cannot pattern mathematics. It is a study of patterns. But you can't sit there and go, okay, well, it's this way, we're going to do this the whole time. No, it doesn't usually work that way. But to answer your question, that's why I do not say this is this, this is this, this is this, and this is this. I don't say that. I say these guys go with these, and these guys go with these. And then when you put it in a mathematical sentence, then you can say LT or GT, whichever one it is. It all depends on if you read from left to right, or if you read right to left. Masalama. Okay? Doesn't matter. And you have these teachers that say, oh, well, you can't do this. Then if you take your kids from Salem to Iowa, Jody has to sit on the same side that he sat on in Salem. He can't sit on the other side of the seesaw. That's what that teacher was saying. You can't put X on the right-hand side. 4 is less than X, or X is what? What does that say?
Same thing.
Same thing. So do not say greater than or less than unless you have something on each side of it. Because you don't know which one it is. You don't know which one it is.
All my life.
Think of a word that has two different meanings. Give me a word that has two different meanings.
Cold and hot.
Huh?
Cold and hot.
No.
Worse.
Same word, two different meanings.
Present, no. Present.
Okay, well, that's a verb and a noun. Present, you are here, but if I just present, if I just say present, which context is it?
Hopefully it gets.
You don't know unless I give you more what? Context. Context clues, context. Dang old English, dang old 101. I can't just say, oh, well, that's this. Present. Which present am I talking about? It's the same association. If you're telling me that you know what this is, then you're telling me you already know what the sides are and you haven't even seen it. That's less than. Is it? Or is 5 greater than 4? 4 is less than 5. Yes, that's less than. What's that? You see what I'm saying?
Yeah.
So there's some things that I want you to patternize or memorize or whatever, but this is not one of them. Scientific notation is not one of them.
I just want to like smack my high school teacher.
Well, it all depends on whether you were listening that day or not, too.
Oh, I was.
There's two sides to every
What's the problem?
sword, two edges to every sword. I'm not going to blame my high school teachers because I know how I was. Okay? Now, let's go back to the beginning. Right here. I'm going to erase this. You don't have to erase it. You can draw a line over here going to this. I'm going to add something else to it. There's two types. Well, you don't have to. You don't have to. I'll just write it over here. Two types of notation. There is set builder notation. I better write that out. Somebody's going to say, what's that stand for? Set. And I like to say that set builder notation is really the pinky. Hold your pinky up. Because it's all you do is you take your answer and you put some braces around it. So it's really not that difficult. So let's say, well, a while ago we did a problem and we got x is greater than 4/5. Everybody agree with that? X is greater than or equal to 4/5. To write that in set builder notation, the only thing you do is put two braces and do this, x such that, and then write your answer. X is greater than or equal to 4/5. That's it. This x means that anywhere in this set where x is a variable, I'm going to use x such that x can be greater than or equal to a quantity of 4/5. That's what it means. Hold your pinky up. Because that is pretty much, so really you could take your highlighter Does this change? No, that doesn't change. The only thing that changes is what? The answer. So this is what you put in to set builder notation. Do I like set builder notation? I'd rather you use interval notation because interval notation stresses that you're reading the graph from left to what? Right. And that's what I'm going to show you next. And it's called interval notation. Because it shows the solution set as an interval. Interval notation is where you're going to use these guys. So I'm going to take my handy dandy highlighter and purple or mauve, and I'm going to highlight this. I'm going to highlight these because that's where you use the parentheses and the brackets. Now I also put something right here. I'll put negative infinity and positive infinity because can you touch infinity? No. So you can't touch, if you can't touch infinity, then parentheses go on infinity and negative infinity no matter what. Now let's go back to the problem we were doing right here. That's why graphing is so important. Because no matter what you say about yourself, a visual representation of the solution set will help you write the answer no matter what. So, which way do we read? Left to right. So we start from negative infinity and we write down in interval notation when we hit the function or when we hit the solution set and when it ends. So our eyes start right here, negative infinity, and we go, 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 ding! Where do we hit the solution set? At where? 4/5. Do we use a parenthesis or a bracket at 4/5? Well, what do we have here? So what does that go with? Bracket. And we keep going to the solution set, we touching the solution set, we touching, and what do we go to? Positive infinity, and what goes on infinity? So the interval notation for this answer is from 4/5 to what? Infinity. Means 4/5, 5/5, 6/5, 7/5, 8/5, 9/5, 10/5, 100/5. 100 over 5, 100/5, 200/5, keeps going. Any number over 4/5 or equal to 4/5 can be used to make this true. I didn't say equal, did I? I said true. So let's pick 5. We said that 4/5 was like 1 1/5 or close to 1. Like a 7/8 inch. It's close to 1. All right? So let's pick 5. 5. What's 2 times 5? 10 plus 3? 13. What's negative 3 times 5? Negative 15 plus 7 is negative 6 or negative 8? Is 13 greater than or equal to negative 8? Yes. And it'll work all day long. Put in 10. 23. Negative 23. Negative 23. Something like that. 23 is greater than or equal to negative 23. Whatever the case may be. So, what do you need to do as a student to get these correct in 6.5? 1. Clear any fractions and decimals. And we didn't cover decimals. I need to cover those. 2. Try to keep variable positive. Now, there are 2 or 3 problems that you can't do it. And I'm going to show you how to do it with a negative variable. And that's the only time you will see me deal with a negative variable is when there's no other alternative. 3. And this is when you get the answer. Solve as 6.2. 4. The fourth is the most important part. Graph solution. That means on a what?
Graphing good.
No, on the number line. I haven't said anything about a calculator. Why are you talking about a calculator?
I just think graphing good.
What's this 6 cent for? 5. And once you graph your solution, put it in set builder notation and interval notation. And the reason you need to put it in both is so you can be used to both. I prefer interval notation, but that's just me. Now I want to cover a couple of problems out of the homework, and the reason I do is they have one in there that you cannot solve, that you cannot get the variable positive. So I want to make sure I cover that. So I'm going to pull up handy dandy homework, and y'all said this is 6.5.
6.6.
Okay, 6.6, thank you. What are you being smart about? You just can't stand it, can you?
Okay.
You just about to bust.
Oh, no. It ain't me.
Mm.
I ain't heard no complaints lately, so, you know.
I know, you have to take it out on somebody, don't you?
That's right.
Did you tell Jessica that you were going to be at the complaint department?
She already knows it.
Okay.
She prefers it that way.
I don't blame her. There it is. No, that's a positive error. Let's see if I can find a negative one. Nope. There we go. All right, I want you to make a note about this one. I want you to put this in your notes. I want you to highlight it. I want you to put stars around it, because this is the one that'll get you on the test if you're doing it the way I taught you. So I'm going to show you how to do it, because this is the only one that you won't see me try to make the variable positive, because there's no way to make it positive. If you notice, what do you notice about this problem? The variable is where? In the middle. So you really can't move it. It has to stay in the middle for your solution set. So the only thing to do here is divide through by -1. And if you do it on one side, you have to do it on all sides. But there's another rule that you have to remember when you have a negative variable. That if you divide or multiply through by negative, you have to do what to the inequalities? You have to flip them. That's why I don't teach a lot of that. Okay? I tell you to use it only as an emergency. And this is an emergency. So I'm going to divide through by -1 all the way through. So I'm going to write it out. -2 is greater than -x and greater than or equal to -6. And I'm going to divide through by -1, because that's the... Now what if that was -2x? What would you divide through by? -2. Okay, I just want to make sure everybody understands that. Divide by -1, divide by -1, divide by -1. And as soon as you divide by -1, the next line, you're going to flip the what? inequalities. So that'd be a positive 2, less than x, less than or equal to 6. And that is your solution set. Now this problem is a good problem that I picked because there's two things I can show you here besides this. And the rule that I'm trying to show you, one rule that I'm trying to show you, if you multiply or divide through, you got to do all the way through, by a negative, you flip the inequalities. If you multiply or divide through by a negative, you have to flip the inequalities. And you flip them right at the last step. That's when you divide through. Right at the last step. Another thing that I would like to bring up here. The directions, and you got to look for this because I really don't care too much for these questions, but sometimes I'll accidentally put them on the test because I'm thinking they're the regular questions. Take a look at this, and I'm going to put it in red. Right there. What does that say? Where x is a what? Integer. What is an integer? It's a 25-cent word for whole number. Okay? A regular 90% of the time question would say, graph the solution set of the inequalities where x is a number on the number line. And if it's a number, then you can have fractions, decimals, percents, and whole numbers. Mixed numbers. You can have anything you want. But since it says integers, an integer is a 25-cent word for whole number, you can't include what? Fractions, decimals, and percents. So which one of these are inclusive of fractions, decimals, and percents? Well, first of all, ask yourself, where are fractions, decimals? Where are they? Are they on top of the whole numbers? Or are they between the whole numbers? Or what? Between. So which one of these number lines, there's several, which one of these number lines are showing just numbers? A. What else? There's more than one.
I can't see the numbers, so maybe that's why it's so quiet in there.
No. I'm asking y'all, which one is including the fractions that's between the numbers?
I can't see it.
It's either.